dear listeners, my name is Stanislavsky. I am a PhD student in Radio Astronomical Institute based in Kharkiv, Ukraine. My talk will be devoted to the instrumental challenges for radio astronomy studies of the universe and challenges for radio astronomy observation on the far side of the next slide. So first, some words about motivation to this approach, unique conditions for radio astronomy observations of the Moon, especially on its far side, will significantly expand our knowledge of the universe by development of suitable of the universe by studying radio emissions at very low frequencies. Very low frequencies not available from Earth. The development of suitable antennas for such lunar missions is for undoubted interest. Experiences building in the ground-based antennas such as GURT, LOFAR, NANUFAR, and others. Low frequencies provide crucial information for future radio experiments on the Moon. Also, perfectly such an antenna would have to generate many ground-based radio arrays will be perceived by prototypes, consisting of a small number of antennas that will be better of quality as consistent of a small number of antennas. That will be of better quality of consistent of a small number of antennas that will be possible. The aim of this work was calculated and produced such an antenna together with preliminary test in real terrestrial conditions. For example, next, this slide shows the most advanced scientific problem in the low frequency radio art. For example, transient phenomena in the near space, petrol of the state of the Earth's ionosphere, extragalactic catalogs of radio sources, for example, radio galaxies, quasar, clusters of quasars. But what's the advantages of the radio astronomy and what is the difference in the image of the sky observed at the different frequencies? This slide demonstrates the futures. The reason is mechanism of radio emissions in the thermal mechanism previous and in the radio the non-thermal one. That means that their behavior is different in frequency. Now it's very important to carry out observations from gamma emissions to radio waves. Because of our atmosphere and ionosphere are not full frequency can be watched from the ground, and therefore the space missions become very popular. However, they don't permit to take a huge radio antenna in space. This slide shows a comparison of the size of terrestrial and space antennas. For example, ground-based antenna may be huge. For example, UTR2 antenna, T-shaped antenna is located 50 kilometers from Kharkiv. It's based on Ukraine. However, the Moon is a specific place for this purpose. To build a huge antenna is difficult. maybe it would be better to start with some good antennas or even single antenna. At the top right image, you can see a typical antenna of UTR dot. At the bottom right image, you can see typical antenna of good. Word type antenna is an effective instrument for radio astronomy observation in the 8 to 80 megahertz. This slide shows you can see possibilities in the radio observation for single active antenna element in wood. And next, some words about design of the future radio observatory on the moon. For example, this depends from frequency range from 1 MHz to 20 or 40 MHz. Radio observatory should be protected from radio emission from the Earth. And if it's necessary to use electrically short pulsed depots installed in the lunar cradle. And if it's possible to locate a correlator on the surface or on the moon and establish connections with the Earth using a satellite repeater, Lagrange two-point. And our project, we have done radio, on the far side of the moon, we can observe radio emissions of the sun, observe pulsar, galactic backgrounds emissions, and radio recognition lines, and more. And what have we done in our project? We have done a numerical simulation of a single antenna array. See results of our simulations in the next slide. We have done analysis of antenna parameters accounting for the lunar soil. We create a single antenna prototype, measure impedance properties, and produce it in amplifier using gas producer. And of course, we testing our building device in the terrestrial shape. Okay. This slide shows the result of numerical simulation of your antenna. Okay, next. And this graphs shows the dependency functions of sensitivity and frequency on our test and simulation. This slide shows the prototypes of our antenna for lunar observation. So the antenna was designed of copper tubes having a diameter of 12 millimeters. The dipole arm length along the midline near 3 and the angle of inclination for the horizon is 45 degrees. And the dipole terminals are located at the height near 3 meters above the ground surface. If you want a more detailed specification for the antenna, I maybe can tell you about it after presentation. Okay, this slide shows the results of observation of galactic backgrounds, radio emissions. This is a dynamical spectrum, frequency, time, and intensity in color. You can see on the image the observations lasted 3 days continuously, and the radiation was observed near 5 or 6 gigahertz and below. And here is a dynamic spectrum of the U-type solar burst. The phenomena is result of the movement of electron beams in the solar plasma along magnetic path. And some words about conclusions. It's most important in my presentation. Some impressive examples of testing of these innovations we present a recent observations of the low frequency radio emissions of galactic background and the sun. Due to the low solar activity currently as a cutoff frequency of the Earth's ionosphere, at our latitudes was noticeably
Thank you.